Hello, everyone, and welcome to another section of the EdSofta. Another section of the EdSofta. Welcome to another section of the EdSofta mathematics JAMB tutorial, JAMB UTME tutorial. So we are EdSofta is an educational software company, and we specialize in building solutions for we specialize in building solutions for we specialize in building solutions for education. So we build tech solutions for education. So take for instance, we have an app and a JAMB UTME app, and the JAMB UTME app is just filled with a lot of resources so that you can prepare seats. And EdSofta is an app that prepares students for JAMB UTME. It has past questions, study materials, and many other features that help students prepare for the exam. Many other features that help students prepare for the exam. So we'll be looking at sets today, and we'll be using the EdSofta app to also look at some questions on sets. And I hope that we, we have a very good time, and we we go home learning a lot after today's class. Okay, so let's look. So it's loading. So while it's loading, let me just be talking about sets. So what is a set? A set is a collection of objects or things that are well defined. So in we use sets in our everyday life without us even knowing it. You have even in the language that we speak, sometimes we say stuff like we have a set of oranges, we have a set of sorry about that. We have a set of oranges, we have a set of keys, we have a set of cars, we have a set. So sets is just everything in life is arranged in a well-defined order. So it's a collection of objects. So when you have an object collected together, that is a set. So if you're in an area, you live in a particular area and all the houses look in a particular way, it's a set of houses. You have green cars just parked in one place, a set of green cars. As long as you have a collection of objects. So as long as there is a collection of objects, as long as there's a collection of objects, as long as there's a collection of objects, as long as there's a collection of objects, you can say that it is a set. So a set, a group, a family, a bunch, a team, they are all sets. And we use sets when we want to start, solving problems that has to do with, understanding how different sets vary with each other. So how do different sets of things affect other sets? So that's where the whole issue of sets comes in. And we have the you can see it now on the screen. Set notations are used to represent. So set is a collection of objects or things that are well defined. So notations are used to represent the elements of a set. So now we don't just please just hold on a minute. All right, guys, let's continue. So set notations are set notation are used to so sorry, it was just a little technical issue. So set notations are used to represent the elements of a set. So when we are talking about sets, there's a way we represent them in mathematics. We don't just represent them anyhow. So there are three basic ways. There's either you use the diagram method, the description method, the listing method. Diagram method, the description method, the listing method. So let me just throw in a few examples. If you can see, look at the slides a bit, you see there's an example for um, description method. So use of words to explain. So let me just switch to the whiteboard so that we can see an example. So if you look at if you're following us with the slides, we talked about different set notations. So we have the diagram method. So we are trying to describe a set of boys. If we were to use the diagram method, what is to mean mind my drawing is that we'll be drawing the what? The boys. We'll be drawing the what? The boys. That's the diagram method. Now if we were to use Okay, so welcome everybody. Sorry about the issue. We had a little delay, a little issue, a little technical issue, but we're back. So what? So we're talking about the notation of the set and what what the three basic notations that we have. We talked about the diagram method, the description method, the listing method. So we use the whiteboard to see some illustrations on what each of these sets look like. So we'll be continuing on going on with the slide and see where it takes us. So there are different types of sets. There are different types of sets. So we are going to be taking each type of set and just talking a bit on each of them, and so that we can see and understand more and better. Okay, so we'll be talking about empty set. We'll be talking about empty. The first set we're talking about is empty set or null set. So from the name empty, this set is just a set that does not have any that does not have anything inside. So basically it's an empty, it's empty. Basically it is empty. Basically it is empty. So this is an example. This is an example. So let's look at this example. So this is an example. So the empty sets are, so if you have a set P and you say that set is empty, we represent an empty set like this or like this. Now, common mistakes that students make is they might do something like this. But if you do something like this, it means that this particular sign is inside the set. So this cannot be said to be an empty set or a null set. So it's either you use this sign or use this sign to represent an empty set or a null set. So you can't represent a null set or an empty set by this sign. This is wrong. So it's either you represent it with what? These two signs over here. So that's just all about empty set. Empty set is just a set that has no element. A set that has no what? Element. So let's pick it up and let's look at the other type of sets. The other type of sets. So the second type of sets that we have on our slide is the finite set. The finite set is the finite set. So let's look and see what the finite set is about. The finite set. The finite set. The finite set. So what is the finite set about? The finite set is a set whose elements are countable. So take for instance now, I say this my set P has five numbers, or this is my set P 2, 3, 8, 9, 12. Now, if you look at this, it has how many numbers? Five numbers. So it is finite. I can count the number of things inside a set. So if I have a bag that's full of balloons and I know that bag contains, or you have a carton, an Indomie carton, and the Indomie carton contains um 11 it contains 24 indomines. That carton is a set of indomines, but it's a finite set of indomines because you know the number of indomines inside. So that's just what finite set is about. Finite set is just telling you that what the not that this set is not is countable. So what is inside is countable. So if what is inside is countable, then it is a finite set. Okay, let's look at the next one. The next one would be infinite set. The next one would be infinite set. Infinite set. Infinite set. So infinite set is just saying, if you can remember when we talked about the when we the first lecture we had, we talked about AP and GP. So when you have a sequence, so let's say you have a sequence that is all the numbers, all no, all integers. All integers is not specific. It can grow as much as 1,000, a million, a trillion, zillion, even as much as far as as numbers could get, up to infinity. So when a set cannot be counted, it is what we say it is infinite. So you can say the set of sand in the beach is infinite. Why? Because you can't count the number of sand in the beach. It is the grains, the particles of sand in the beach. It is almost as infinite as they get. So if you have a set of all positive numbers, my brother, all positive numbers can go from 1 to 3 million to 1 billion to 1 trillion to 2 zillion, and keep going, keep going, keep going, keep going, to a position where numbers sef, they've not given a name to such a number. And you can see that if you don't have that, you can see that so that is infinite. It cannot be counted. So that's just an infinite set. So we've looked at empty sets, we've looked at finite sets, we've looked at infinite sets. So let's move to the next. The next one that we'll have, as we saw in our slides before, the next one we are going to have is the universal set. The universal set. The universal set. The universal set. So now, under the universal set, so this is like the set that holds all the elements under a discussion. Now, under a discussion means that if we are talking about the boys in the class, if we are talking about a class, now that class is the universal set because it contains all the students, from which we can now start to piece out smaller sets from it. So we can say, okay, all the boys in the class, all the girls in the class. So if you have a universal set, it's usually denoted with this symbol U, or there's a way they even write the U, but it's usually denoted with this symbol U. So if you have a set of 35 pupils in a class, 35 pupils in a class. So the discussion you are trying to have is about the class. And there are 35 pupils. So that class is a what? Is a universal set. You are not discussing outside the class. So anything outside the class is none of your business. But everything inside the class, it is under that universal set. So under these 35 pupils now, you can now say, okay, let's talk about the that will now bring us to our next type of set, and that's the subset. The subset is now when you say, okay, under these 35 pupils, I want to talk about the boys. So I say, okay, 12 boys in the class. 12 boys in the class, how many girls are we going to have? We're going to have 23 girls. So you see, I'm beginning to piece out smaller sets. 23 girls in the class. Just 23 girls in class. We can also piece out the people that offer physics. We can say, okay, in the class, 24 people offer, 24 pupils offer physics. Are you saying I'm piecing out smaller sets? These smaller sets that belong to the universal set are what we call the subsets. They are what we call what? The subsets. So the subset is a set that if all the elements is in a subset are inside the universal set, then that subset is a subset of the universal set. So the set physics is a subset of the universal set if all the elements inside physics are also inside the universal set. And that's true because inside that class, 24 pupils that are doing physics inside that class are also in your universal set that contains all the pupils in that class. So when you're talking about a class, if you're talking about if in a discussion, the set that contains all the elements in that discussion is the universal set. Then the set that now contains, so inside that universal set, you can now piece out smaller sets. You can piece out the boys set, you can piece out the girls set, you can piece out the physics set, you can piece out the people that are offering chemistry, piece out people that are offering um, geography, piece out people that are offering um, um, government, piece out those people. So with those smaller sets that you are piecing out, that everything inside their set is also inside the universal set, those sets are called subsets. So that's so we've discussed empty sets or null sets, finite sets, finite sets. We've also discussed we've also discussed universal set and also subset. So moving on, there are still other types of sets that we can discuss on. So we can talk about the power set. We can talk about the power set. So the power set, there's power set is just if you have a set A, if you have a set A, then the power set of A is, so if you have a set A, we have a set A, we have a set A. The power set of A, denoted by PA, is the set of all possible subsets AA of A. So now you have, it is more or less like the universal set. Now you have a universal set U. Now the power set of this universal set is now the set of all possible subsets inside the universal set. So take for instance, you have, so all possible subsets inside the, so let's say the discussion was about a class, a basic 9 class. Inside a basic 9 class, there are a number of subsets that we can piece out. An example of such subsets is the boys set, that's the boys, in the class, the girls, the people offering are Greek, the people offering physics, even down to the boys that know how to play ball or the boys that like football, so the football set. So you can see, so if you have a set that contains those different subsets, if you have a set that contains those different subsets, that set is called a power set of the universal set. So the universal set contains all the elements, but the elements of a power set are sets. The elements of a power set are possible sets. So boys is a set, girls is a set, agric or people that offer agric as is a set, people that offer physics is a set, people that offer football is a set. They are all sets, but they are elements of the what? The power set of the universal set. Because so just like the elements of a normal set are elements, but the elements of a power set are sets. That's gives it the name power because it's like it encompasses sets. That's about power sets. Then we now want to talk about the last form of sets. The last form of sets. And the last type of set is the equal set, or we won't call it a form, we'll call it like a phenomenon where sets are equal. So it's a mistake where some people think that if you have a set, I write 1, 3, 2, 4. You have another set B, I write 1, 2, 3, 4. You now say that these two sets are not the same. No, A is equals to B because A has all the numbers of B, B has all the numbers of A. It is regardless of the, it is regardless of the it is regardless of the arrangement, as long as they contain identical and equal number of elements regardless of the order, they are equal sets. So that's just what equal set is about. So you cannot say because they are not arranged, you will not say maybe these ones are not equal. But because they are arranged, they are equal set. So let's go back to the slide and see where the slide takes us. Thank you very much. I'm moving on to, I'm going to be sharing my screen. I'm going to be removing the whiteboard and bringing on this, the, the, the slides. Okay, so I hope we can all see. So now we're going to be talking about operations of sets. So what operates on set? What operates on set? I don't really need the board for this. The first one we have here is the first one we have here is the first one we have here is the union of sets. So the union of two sets A and B is the third set which contains all elements of A or B or both A and B. So take look at the example. If A contains 1, 2, 3, 4 and B contains 5, 6, 7, 8, A union B will be 1, 2, 3, 4, 5, 6, 7, 8. That is the union of sets. The union of sets will be what? 1, 2, 3, 4, 5, 6, 7, 8. Let's move on. Let's move on. Intersection of sets. We have two sets, A and B is the third set which contains only the elements common both A and B. So if A is equals to 1, 2, 3, 4 and B is equals to 1, 2, 7, 8, A intersection B will just be 1 and 2. Why? Because if you look at A, you can see 1 and 2. If you look at B, you can see 1 and 2. So that is common between the both of them. So that is the intersection of the two sets. Now, the last set operation is what we call the complement of sets. So if you have a set, a set P, you have a universal set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You now have a set P that only contains 1, 2, 3, 1, 2, 7, 8. You now want to get the what? The P prime. If you see very well, you can see, if you look very well, you can see above the P, there's a little apostrophe. That's to show you that it's a complement. Or you can say P prime. Now, the P prime will be what? All the elements in the universal set that are not in the set P. All the elements that are in the universal set that are not in the set P. So in this case, it will be 3, 4, 5, 6, 9, 10. In this case, it will be 3, 4, 5, 6, 9, 10. Okay. Now, this is just an illustration. So when we are talking about set theory and we want to start taking it into real life, we don't want to be working with it's easier for us to work with what we call the Venn diagram. So we can make the theory of set comprehensible using the Venn diagrams. If you look at this is a class. The class contains two sets of people that are doing maths, people that are doing economics, and people that are doing maths and economics. Now, if you look very well, I would be switching to the whiteboard so I can illustrate this much more in a much more understanding and interesting way. So just give me a minute. Okay, so if you look at that diagram very well, you have something like this. So we had physics here, you have mathematics here. So this is a class. In that class, they tell you that five people are doing physics, four people are doing maths, and three people are doing physics and maths. This three that is here denotes what? The intersection M intersection P. Why? Because it shows the people that are common to both maths and physics. So in this case now, if they ask us what is the number of people that are doing maths, our answer will be 7. Why? Because it will be 4 plus what? The 3 people here, because they are doing maths. Number of people that are doing physics, it will be what? 8, because it will be 4 plus the what? 3 here, because they are doing what? Physics. 5 plus 3 here, because they are doing physics. So Venn diagram just helps us to illustrate our set more in a much more organized way, so that we don't have to go through the rigor of just writing it and it all looks so confusing. So with Venn diagram, you can easily solve some of the equations and some of the problems that you have. So we'll be moving to solving some of the questions, some questions. We'll be moving to solving some questions. So let's, so I'll be switching the screen to my EdSofta app so that we can look at some of the questions in the EdSofta app and then solve those questions so that we can move on. Okay, this is the EdSofta app. Like I said, we build solutions where you can, practice practice questions. You can choose topics, whatever you are interested in. Economics, you want to see different topics, theory of cost and revenue, just name it. That's what our app, we build solutions for our pupils. So for the course of this lecture, I've saved some questions that I would like us to go through so that to solidify our our knowledge of sets. So let's look at this question. It says in a class of 40, I think we can move the questions to the board so that we can solve it. Sorry about that. I'll be switching the screen to the board. So I'll be taking the questions from the heads of the app, switching the screen to solve the questions on the board. Okay, let's move on. All right. So the question goes thus. Oh, sorry. So the question is thus. In a class of 40 students, In a class of 40 students, 32 offer mathematics, 24 offer physics, and 4 offer neither mathematics nor physics. How many offer both mathematics and physics? So we can represent this with a Venn diagram. So we have something like this. Hey, sorry about that. So we have this. So if you look at it, we have two sets of people: people that offer maths and people that offer physics. But big. So we have physics here, we have maths here. So from what they told us we should find how many people are offering both mathematics and physics. How many people are offering both mathematics and physics? Now they told us in a class of 40. So the universal set, there are 40 students in a class of 40. So you know that the whole class, so there are 40. So what is the amount? So you can just put number of universal sets is 40. They said, and for they now said 32 offers mathematics. So 32 out of the 40. Now note, we don't know how many people offer both. So we just put X here. But they say 32 offer mathematics. So the number of people that offer mathematics only will be 32 minus X. Why? Because X offers both mathematics and physics. So for us to know the people that offer mathematics alone, it should be 32 minus X. And the number of people that offer physics will be what? 24 minus what? X. So we have to find, and they say four people neither offer what? So they will just be outside the set, but they are still inside the universal set. So what we are now looking for is X. How many people offer both how many people offer both maths and physics? How do we fix that? What we just need to do is, we know that if we add everything here, it must be what? The universal set, or else, well, or else the question is wrong. So what we just do is just do 32 minus x plus 24 minus x plus 4 is equals to 40. This can cancel this out. We have 32 plus 24 minus x plus 4 is equals to 40. We can bring x to this side. We can add all this. So 32 plus 24, we have 6. We have 56 plus 4 minus x is equals to 40. So this will become what? 60 minus x is equals to 40. X will be 60 minus 40, which is equals to 20. So what we have is what? X is what? 20. So how many people offer both maths and physics? Our answer would be 20. Our answer would be 20. Our answer would be 20. So this diagram can be redrawn as, I can, this diagram can be redrawn as this. 32 minus 20, 12, 20, 4, 4. If you notice, when you add all this, you have what? 40 at the end of the day. So that is just a little, that's just one question. Let's see if we can still solve some more questions before we call it a day. All right. I seem to have found another question. So let's see. These are all JAMB questions collected from the EdSofta app. So if you need to prepare for JAMB, you can just go to Google Play Store to download our app, and you can activate it for just for just 1,500 naira per activation. If you're also if you're also preparing for WAEC, we have a WAEC solution that you can also buy for the same price with, and it contains every all the past questions, study materials you need for your WAEC. Contains all the past questions, study materials for your, contains your WAEC syllabus. It is everything you need for your WAEC. All right, guys. So let's continue. So we have this. They said in a survey, 50 newspaper readers, in a survey of 50 newspaper readers, so the universal set is what? 50. The universal set is what? How many elements are universal set? 50. 40 read champion and 30 read guardian. How many read both? So we have our Venn diagram. We have champion. We have what? Guardian. So they said we should find how many people read both. That's in the middle, because the people that intersect, they read both what? Champion and guardian. So how many people read guardian? 30 minus x. How many people read champion? 40 minus x. We do it the same way we did the last question. 40 minus x plus x plus 30 minus x is equals to 50. This can cancel this out. 70 minus x is equals to 50. X will be 70 minus 50, and our answer is what? 20. We can also draw this in a, so this can now be drawn in a different way. This can now be drawn in a different way after the answer has been gotten. So number of people that read champion only would be 40 minus 20, that would be 20. Number of people that read both champion and guardian is 20 from our calculation. And number of people that read guardian only would be 10. So I hope we are following. So let me check for another question. So we have another question here. Sorry about that. Okay, this is another question, not really a Venn diagram question, but another question on set. So it says if P is a set of all prime factors of 30 and Q is a set of all factors of 18 less than 10, say we should find P intersection Q. All prime factors, so all prime factors between P, so all prime factors of 30. So how do we get the prime factors of 30? How do we get the prime factors of 30? How do we get the prime factors of 30? First, we need to get the factors of 30. How do we get the factors of 30? We have 30, we have 1, 2, 3, 5, 6, 10, 15, 30. So the prime factors we have are 2, 3, 9. So P just contains 2, 3, and 5. Sorry about that. Then for 18, they said we should find all the factors are 1, 2, 3, 6, 9, and 18. So Q, all the factors less than 10, so 18 is out. So Q is going to be 1, 2, 3, 6, and 9. They now told us to find P intersection Q. From our slides, you know intersection means the common ones. So which one are common? 2, 3, 2, 3. So our answer is just 2 and 3. Wonderful. So that will just be our answer to the question. So note all these questions are JAMB questions, and the their likelihood of similar kind of questions coming out is very, very high. Okay, so let's see if we can look at one more question. Okay, let's see if we can look at one more question. So this question is telling us that in a youth club with 94 members, 64 like 60 like modern music and 50 like traditional music. The number of the members, the number of the members who do not like the number of the members who like both traditional and modern music is 3 times those who do not like any type of music. How many members like only one type of music? So this is going to require a bit more technicalities, but anything is possible if you put your mind to it. All right, let's go on. So you have to first draw a Venn diagram. So we know our universal set is 94. And so they said those who like modern music are 60, and those who don't like modern music are 50. Those who like traditional music are 50. Let's take a look at it again. Yeah, 50. You now said the numbers of those who like both traditional is 3 times the numbers of those. So let's say the number of people who don't like music at all is X. So the number of those who like both modern music and traditional music will be 3x, because it tells us that what it is 3 times. 3 times. So now, but here will be what? 60 minus 3x, and here will be what? 50 minus 3x. So what do we do? Oh, same thing that we've been doing. 60 minus 3x plus 3x plus 50 minus 3x plus x is equals to 94. This should cancel this. 60 plus 50 minus 3x plus x will give us 2x minus 2x. So that's 110 minus 2x is equal to 94. So 2x minus 2x will be 94 minus 110. If you move this one to this side, so minus 2x will give us minus 16, and x will be minus 16 over 2, which is over minus 2, which is 8. So if our x is 8, it means that our new diagram would be 60 minus, so x is 8, so 3x is 24. 60 minus 24 would be 36. This will be 26. And they now said the main question asked us that how many members like only one type of music. Only one type of music. So the only people that like one type of music are the people that like only mathematics and the people that like only traditional music. So our answer to the question, answer will be 36 plus 26, and that will be 62. 62 people. 62 people like only one type of music. It doesn't matter the type of music, but 62 people liked only one type of music. So at there, we would call it a class, or we would call it a day. So now, this tutorial is brought to you by EdSofta, powered by EdSofta, and we are an ed tech company. And what we do is to do solutions for educational exams. So like JAMB, like WAEC, name it, we have solutions for you. So if you want to be able to use our app to get questions, just go to Google Play Store or go to our website. You can download it for for your Windows and for your Android, and you need to activate it to be able to access the full features, and I tell you, it is worth it. So to access the full features, you just need to pay an activation fee of 1,500, and that will be all. Thank you for joining me in the tutorial today, and God bless you. So I'll see you in the next 15 minutes for our last tutorial on equations. So we'll just be solving simultaneous equation and quadratic equation. Thank you very much, and God bless you.